Welcome to this session. In this lecture, I will be taking more depth into the energy conservation principle and conservation of mechanical energy. As you are aware that in the in the last session we have discussed about these concepts, but I will take up in depth. Right now, there are two kinds of forces defined. There are two kinds. One is conservative forces and another one is non-conservative forces. What are these? What is the function of these? I will not take up because you are Mr. Aditya Agrawal in class 7th, but the nomenclature you should remember. These are gravitational force, magnetic force, electric force, and spring force. I think if you recall, I have already told about these forces when you were studying in class 6th, and I have shown you some thing about these. Now, what are non-conservative forces? Tension force, second friction force, third one is air drag, normal force, and another one is applied external force. So these nomenclature is defined for various kind of forces, and potential energy is only defined for, I will use conservative forces as CF and non-conservative forces as non-conservative force, is only defined for CF. That is wherever you see a potential energy, only these kinds of forces, gravitational force, magnetic force, electric force, and spring force, will be acting on the body. Now, there is a work done by conservative forces. There is a law which can be proved conservative forces. The work done by conservative forces is equal to minus of U. What is mu? Delta U is equal to change in potential energy. You have to remember this formula. I will give you example of this also. And minus delta U is negative of change in potential energy, and delta U is equal to U final minus U initial. So what is the meaning of this function? That it's change in potential energy between 2 points. The negative of this is work done by conservative forces. If you recall, when we were dealing with potential energy in the last lecture, we have defined potential energy in terms of height h. And we mentioned in that lecture that at height h the potential energy is mgh. Now I will try to prove the above formulation for this. What is the work done in bringing the ball from height h is equal to 0 to height h? Work done is equal to force into displacement. Here the force is mg acting in the downward direction and displacement is in the upward direction, so there will be a minus sign. So work done is equal to minus mgh in bringing the ball from A to B. And what is change in potential energy? Change in potential energy, delta U is equal to final potential energy is mgh and initial potential energy is h is equal to 0, so is equal to 0 is equal to mgh. Now you see from this 1 and 2 we can very well verify that WC is equal to minus of delta UC. Again I am repeating that potential energy is only defined for conservative forces. Now I will define the energy principle. It says energy principle for kinetic energy. It says that work done by all forces is equal to change in kinetic energy. What is work done by all forces? What are all forces? The all forces is equal to conservative force plus non-conservative force plus applied force. There is one also force called pseudo force, which we will study in class 11, but just name it here. These are the various kind of forces which can act on a body. Pseudo force acts on a non-inertial frame when there is a non-inertial frame. What is this? What is non-inertial frame? I will not explain here. But only remember that there is a pseudo force. So work done by all these forces is equal to work done by conservative force plus work done by non-conservative force plus work done by pseudo force plus work done by external force. And our this work in this theorem says this is equal to half m v final square minus v initial square. That is change in kinetic energy. Now if you recall that work done by conservative forces minus delta U. So our principle becomes minus delta U plus work done by non-conservative forces plus work done by pseudo force plus work done by external force is equal to change in kinetic energy. Now we take a situation in which only conservative forces are acting on the body. That is Fnc is equal to 0, non-conservative force is equal to 0, W pseudo force is equal to 0 and W external is equal to 0. In this situation, what is the equation becomes W conservative force is equal to change in kinetic energy. This is we define Ke final minus Ke initial. Now this we have already defined. This is minus delta U. This is minus of U final minus U initial. So this can be written as minus U initial plus plus U initial minus U final is equal to KE final minus KE initial. With this we can say U initial plus KE initial is equal to KE final plus UF final. Now this KE final plus UF final or U initial and K initial, we have proved that KE plus PE for a non-conservative for a conservative force only acting is equal to constant. This is called mechanical energy. Mechanical energy is equal to KE plus PE, and now we have shown that for conservative force only acting, this is constant. This is called conservation of mechanical energy. Conservation of mechanical energy. Mechanical energy, and it is a special case when only conservative forces are acting on a body. So with this I think I have completed your syllabus for energy part. Thank you.